Alright, so we're into the second section of Unit 8, which is all about quadratic equations. So we talked about, in the last section, the axis of symmetry, the vertex, and a parabola. And then now we're going to learn how to graph an actual quadratic equation. So when we did it last time, you really just had to draw either, we just kept it simple. If your A was negative, you drew an upside down parabola, or parabola opening down. And if your A, and then remember, your axis of symmetry is the line that goes straight down the middle through a parabola. And your vertex is either going to be a minimum, because it's the lowest point. If it's the lowest point, then your parabola is going to touch that lowest point and then turn around and be the highest point. And it's the same way. Your parabola is going to go, because remember, we go left to right. So your parabola is going to go up, 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 go up to the maximum, and then it's going to turn right back around. So remember, when you have this line of axis of symmetry tells you that when you fold the parabola, if you folded it on this half, you would get exactly the same, because it's symmetrical. So to graph our quadratic equation, we're going to have to find our axis of symmetry, which will be ax squared plus bx plus c. In your vertex, once you have your axis of symmetry, plug that x value into your equation and find out what your y value is, and your vertex will be x comma y. So then you have to put the vertex in the middle row of the table. Put the vertex in the very center. And then we're going to fill in the table of values using our calculator. So we're going to put it in our x values. So we want to look at the x values to the left of the vertex, and we want to look at the x values to the right of the vertex, and then plugging in each x value into your equation to see what y value you get. Because remember, every input has one output. You can have one x value give you two different y values. Then it will not be a function, and quadratics are functions. Then once we have our table filled out, then we're going to go plot the points. We'll have 5 points to plot on our graph, and then we will connect it to make a nice smooth parabola that either opens up or opens down. So starting on this one, y equals x squared. X squared is more of your parent function. It's the basic quadratic equation where your a is equal to 1, your b is equal to 0, and your c equals 0. To be a quadratic equation, you have that your first term is to the second power. This just means that your b, if you wrote it out all the way in its standard form, then you would have plus 0x plus 0, and we just don't write the zeros. Alright, so then for your axis of symmetry, x equals negative b divided by 2a. Well, that would be negative 0 divided by 2 times 1, which is just 0. Anything 0 divided by anything times 0 is just 0. So then your axis of symmetry will be x equals 0. So it is the line where x equals 0, which is your y-axis in this case. And then to find your vertex, your x value is 0, so you want to know what is your y value when x is 0, so put 0 back into your original equation, which would be y equals 0 squared, which would just be 0. So then your y value is 0 as well. So then placing these 0, 0 in the very center, to the left of 0 we would have negative 1, negative 2, and to the right we would have 1 and 2. Your 0 and the 2 x values to the right of your 0. And then for each of these, we'll put in, using our, we will have, if our function is x squared, then when you put negative in for x squared, then you would have negative 2 squared. So open parentheses, negative 2, close parentheses squared, enter. So when you put negative 2 in, you came back with 4. And then doing it again, but with negative 1 this time, you would get back 1. Doing it again with 1 squared will give you back 1, and then 2 squared will give you back 4. Alright, so once you have your table of values filled in, then you go graph them. I like to plot my vertex first. So at 0, 0, I'll put my first dot, because this is going to be the center of it. So the other positive 4, so I'd go to the left 2, and then up 4. And then negative 1, positive 1. X values, remember, means that your X value is how far left or right you're going to go, and your Y values are how far up or down you'll go. If you have negative X values, you go to the left. If you have positive X values, you go to the right. Same if you have positive Y values, you go up, and if you have negative Y values, you go down. So plotting negative 1, we would go left 1, up 1. The axis of symmetry. So in this case, here's our axis of symmetry. It is the y-axis that goes straight through the middle. That means that the 2 dots that you plot should be at the same level. So these next 2 dots are at the line y equals 1. I just shaded them differently. These next 2 dots are at the same level. So then you just need to connect your dots. I like to connect this curve. And then following the curve, make sure you go through the next point, and you just follow that curve to the best of your ability. And put an arrow, because quadratics, they do not stop. They will keep going. Following this curve, going in the other direction. And bam. If you notice these lines, if you notice this parabola is just a curved line, and lines never end. So these arrows tell us that this side is going to keep going to negative infinity. It's going slowly but surely off to negative infinity. This right side is going off to positive infinity. So one way to write that would be negative infinity to infinity, but that just means you're hitting all the numbers in between there. So you could also write the set R numbers, because you're going to hit every single real number. You can see where it's hitting decimals right here, and right here, and right here, and right here, or it'll hit a whole number. It's going to hit everything. Your range. Starting from the bottom and going up, the first place you touch it is at 0, and then from there you touch it everywhere else. It's going to touch every line going off to infinity. All y values greater than or equal. Range is y. And then we had 0. And your y is going to stand for your graph. So your graph touched all numbers greater than, and you have to include that equal sign because you did actually go through 0. As you can see right here by your vertex, you went through 0, 0. And bam. Then you have your axis of symmetry, your vertex, your domain, your range, your table of values, and graphing it. And even if you had graphed this in your calculator, you'd go to y equals, and then you would just put x squared. So x squared, hit graph, and you can see my graph may not be as pretty, but they are both through the same line, going through the same points. So if you had hit second table, go up a little bit, you can see at -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Alright, and then moving on to number 2. No, I don't want to do number 2. Okay, continuing on, we're going to do number 4 next. So number 4 has that y equals -2x squared plus 4x plus 1. So this one actually has all 3 values. So your A is -2, your B is a +4, and your C is a +1. My pencil just ran out of lead, so I have to get another one. Always have a backup pencil if you don't have mechanical, like you don't have time to grab your extra lead. Okay. So then finding our axis of symmetry, minus b, x is going to equal minus b divided by 2a Well, our b is 4, so negative 4 divided by 2. Our a is negative 2, so divided by 2 times negative 2. This is going to give you a negative 4 in the numerator, and 2 times negative 2 is going to give you a negative 4 in the denominator. Now when you have the same thing divided by itself, that is equal to 1. So your axis of symmetry would be x equals 1. So your vertex, you want to know what y equals when x is 1. So putting 1 back into your equation, is going to give you that y equals negative 2 times 1 squared plus 4 times 1 plus 1. Now, if you have your calculator on hand, you can put it in exactly how it looks. So you can put in negative 2. Let me back up. So negative 2, open parentheses 1, close parentheses squared, plus 4, open parentheses 1, close parentheses, plus 1. Hitting enter, that's going to give you 3. So you would get that your y equals 3, so you could go ahead and put the 3 here. If you do not have a calculator, then you can find this by hand by saying what's 1 squared. Well, 1 times anything is 1 times itself is 1, and 1 times a negative 2 is negative 2. So then this would just be y equals negative 2, 4 times 1 is 1, plus 4 plus 1. And when you're at addition and subtraction, make sure you do them from left to right. So you would do negative 2 plus 4 first, which would give you a positive 2, plus 1, which would give you that y equaled 3. So just remember to follow the rules of PEMDAS.
Okay, quick question.
Okay. So PEMDAS, parentheses, exponents, multiplication, division from left to right, and addition and subtraction from left to right, because we read from left to right. Okay, continuing on. So we're going to put 1, 3 in the very middle. And to the left of 1 we have 0 and negative 1, and to the right of 1 we have 2 and 3. Now to find each y value for each of these x, you have to put negative 1 in for 1, negative 1 in for x. So instead of 1 we would have put in negative 1, and then put in 0, and then put in 2, and then put in 3. So using your calculator, a calculator you can find online, because there's plenty of online calculators as well, we're going to start putting this. So we're going to start with negative 1. So it was negative 2 times, replace positive 1 with negative 1, squared, plus 4 times negative 1, plus 1. Enter. That'll give you back a negative 5. So your y value for negative 1 would be negative 5. And then following that again, except instead of negative 1, I'm going to put 0. And my calculator lets me copy and paste. If not, you could just redo it exactly, except here I'm going to put 0. Ooh, I did not mean to. Parentheses, and then right here I'm going to put there we go. So now instead of negative 1 we have 0. That gave us back 1. And then doing that again, except this time we're going to be using a positive 2. Positive 2, and that gave you back 1. And then again, but instead we're going to be using a positive 3. So that should give you back -5. So because this is symmetrical, around your vertex, the x value immediately to the left and immediately to the right should actually give you back the same y value. And then the x value 2 places to the left and 2 places to the right will give you back the same y value. Okay, and then graphing this by putting my vertex down first, so over 1, up 3. And then you don't go, you move, you stay at 0 and you go up 1. And then -1, -5 would be left 1 and down 5. And then plotting 2, 1, so start at the origin, go over 2, up 1. And then do 3, -5, so starting at the origin, go to the right 3 and down 5. And because their y values are the same, remember they're going to be the same height. So then connecting your curve and continuing down, don't lift up your pencil, keep going, make sure you go through that value. It's okay, it's a little off. And then I like to start again at the origin and just follow the curve I already have. Whoops, that one was not a very good one. There we go. That's better. So right here, after it curves, it should be as straight of a line as you can get it to be. And then looking at this, you can see again it doesn't end, so the domain is all real numbers. And your range, going from the bottom, this is actually going to a negative infinity. So when your a is negative, that means your smallest number is going to be negative infinity, and you have a maximum. So the highest number you're going to reach is 3, which is your y value. So then putting y and 3 down, because you have to put either your minimum or your maximum down. Your graph goes to the bottom, so that means that you're looking at all y values less than or equal to 3.